Hello guys, welcome to second question of the Leetcode problem list. This is day 2 of adding two numbers. The first problem we had was of adding the sum of two numbers of an array. You can check it out on our channel. We have made a playlist of all these DSA questions and we're starting from 1 until infinity. Whatever problems you have in the Leetcode, we'll try to solve all of them and become master from scratch. Okay, so let's have a look at this problem statement, and it's given that you are given two non-empty linked lists represented two non-negative integers. Non-negative integers means all the positive integers starting from 0 to infinity. So we have 2, 4, 3, 5, 6, 4. Digits are stored in reverse order. So digits are stored like 342 is stored like 2, then 4, then 3. So if you know a linked list, it will be better for you to have some basic knowledge of linked list to solve this problem. That will be better for you, as at any point of time you have to learn linked list if you are learning DSA. So you better, if you don't know linked list, you better learn it. And let's start now. And each of the nodes contain a single digit. So each of the linked list node has a single digit. Okay, and add the two numbers and return the sum as a linked list. So we have to add these two numbers which are in reverse. So the answer of this will be 7, 0 and 8. And the explanation, the output will be 708. And we don't need to worry about this explanation. We just need to return this 708. A linked list which contains 708. Okay. So before starting, let's take an example of how we are going to add this and how does a linked node, how does a list node works, and how are we going to work with L1 and L2. Okay, so first things first, that consider this is L1 and this is L2. Okay, so linked list, this is one linked list, this is another linked list. A linked list is nothing but a list of nodes. Okay, so multiple list nodes are linked list, consider. Okay, so this is one, this function is one inside here, one here, one here. So each of them has a value and each of them has a next value. The next value it points to. So this list node points to this because it has next address to the next list node. This has address to the next list node, and this doesn't have a next, so it will be null. Like this, we have this linked list also, and now we have to add this both. Okay, so if you don't have next, it will be null. Okay, if you don't have next, it will be null. And how do we get to know if a linked list is null or not? We just check the L1 wherever our header is. Wherever our header is, it will be null. Consider we are pointing our header to this last node dot next, and there is nothing at the next, so it will be null. So L1 will be null, right? So let's just start by writing the code so you will get a better grasp of what we are trying to do here, because we are going to use basic uh, code here, and I think it will be very easy once I start writing the code to understand what we are trying to do here. But I will still explain what we are trying to do is, first we will take this number which is from L1 dot value, this is L2 dot value, we will add this, we'll get 7. We'll now move forward the head with its next value. So L1 dot next, so L1 is equal to L1 dot next, which will be 4. So like it's like incrementing I in a for loop. We are incrementing, we are moving this head to the next node. Incrementing, we are moving the head to the next node. So in linked list, instead of in like how we do in for loop, we don't increment the any variable, we move the head. Okay, so if the head is here, we need to move it here. So we'll give the next address to the head, so that head goes here. Okay, I will show you how. So for now we have to we also see here we have to return a new list node. Okay, so for to return it, we have to define a dummy list node like L3, which will be containing the sum of this numbers. Okay, so L3 is equal to a new list node which will contain 0. Okay, so for visualization I will write here the list node. Okay, currently this is our linked list. Okay, linked list L3, and we have 0 inside it. Okay, and L3 is pointing to this. Okay, now we will also need to define a carry, because as you see here 6 and 4 becomes 10, then we need to add the carry in the next number. Okay, so that's why I need a carry here. As you know, this is a single digits, each node contains single digit. We need to also consider carry here. This is not a normal number calculation, it's calculation of two linked list. Okay, addition of two linked list. So now what we'll do is we'll check, we will run a for loop or a while loop, and most probably a while loop. Okay, because it will check continuously if the linked list, the head of the linked list L1 L2 is null or not. If any of them is null, we will return. Okay, we will stop. Got it? So let's write a while loop which says L1 is not equal to null, and or we can say or, because there can be a case where number will be 4 digit and 3 digit, 5 digit and 3 digit, 3 digit and 5 digit. In that case we need to keep on moving forward with the another list node, right, is equal to null. In that case, so if, because we need to check for both linked list, key we are here, okay, we are here. First we take 2, we add 2 with this 5. Okay, now we add 4 with 6, we add 3 with 4. Consider we have another number here like 1. So in that case, if we write here and okay, actually no, what I'm talking is if we uh, write here and what will happen? Let's just think about that case. Actually this will be wrong. And will be wrong because L1 is not equal to null. Let's see, at a point L1 will be null because we are going to point L1 to the next number. So if we do and, consider we are at the end and L2 is 1 and L1 is 1. So in that case, what will happen? So we'll keep and for now and we'll see what happens. So this is a teaching for us also what happens, because we all are learning together. and we are not able to visualize something, we'll keep it as it is and mark a point here, y and not or. Okay, what we are going to do is we are going to check if L1 is not equal to null. If it is not equal to null, that means we are not at the end of the linked list, and we are going to sum. Okay, yeah, we haven't defined sum yet, so sum is equal to 0. Okay, and sum plus equal to L1 dot value. Because it's not equal to null, that means it is at some of the point. Okay, consider 2. It is a 2. We are definitely going to start from here till the end. So here it is here, and the value is 2. So we'll also write here value is 2. Okay, and as soon as we take this value, let's move head to the next one. That is L1 is equal to L1 dot next. It may be null, it may be another value, that is 4. If we are at large, it may be null. If we are at the end of this linked list, if there is null, next value is null, it will be null. Whatever it is, it will be assigned. Next, for L2, we also do the same thing, and here we will say sum plus is equal to L2 dot value, which will be in our case 5. Okay, and L2 is equal to L2 dot next. Now we are here, okay, 4 and 6, but not until our additions are done. So you see 2 and 5 is 7, right? So I think our addition is correct. What we'll do is we will create a new linked list. See, already we have a new linked list, but we will add a new list to that node. We will link that list. So linked list is nothing but list of nodes connecting each other, right? Imagine like that, and of course it is like that. Just I'm saying, for those who are new to this, to imagine it like that. Then we have L3 dot next is equal to L new list node of sum. Okay, and I think that's it. And definitely at the end we need to return L3 dot next. But you see, what I'm doing here is I'm returning the next value. Consider 2 and 5 7. So after 0 we have 7. Okay, and after that it will be definitely 0 and also 8. Okay, but what I'm saying is I'm returning L3 dot next. So we will definitely need this next, L3 dot next. Okay, but what I want is I want to return the head of the linked list, which will be here 708. We definitely need to define link node, list node. Even if you don't define it, here if it is undefined, it will take 0 value. So what happens here is 0. We can take a temporary head, okay, and call it as current head is equal to L3. Okay, and we can do operations on that. Okay, in that case we are ready to see. In that case our L3 is still at 0, and all these operations happen, and then we return the head, that is L3 dot next, that is 0 dot next, I mean this dot next, which is 708 and all whatever the end it is. Okay, so in that case that will be correct answer. So now you see we are missing some of these points here. Like consider the next number is 4 and 6, correct? So in that case our additions will be 6 and 4 will be 10. But how do we now add here? I mean, how do we, which digit should we keep here and which digit should we keep at the carry? Okay, because we have different carry, we are not using it anywhere. So you see here that because this is a reverse, because these numbers are in reversed order, okay, and we are doing a reverse operation, we are doing reverse addition. Okay, so instead of 342 plus 465, which answer will be 807, we are doing 243 plus 564. Consider like that. Okay, in that case what happens is 4 plus 6 is 10. So we should not keep 1 here and 0 here, because it's not it's a front line operation like a straight operation, it is reverse. Okay, so we need to keep 0 here and keep 1 as a carry. Okay, normally operation addition, what do? We will keep 1 here and put 0 here, right? And here, but here this is a reverse operation, a reverse order. This in reverse order we need to keep 0 here and 1 as a carry. Okay, so what we'll do here is, how do we take 0 from the 10? So we have 6 and 4, our next node will be sum, and how do we only put I mean, if we have 10, how do we put 0? Because we need only single digit number. In that case we can divide by, we can do a mod of 10, because if you want to convert any single digit any 2-digit number into a single digit, we do a mod of 10, because we also definitely have single digit numbers, and any we do any maximum single digit numbers like 9 and 9, it will be 2-digit number only, and to convert 2-digit number into single digit number we use modulus operator. So consider here it is 12, what we will get? We'll get 2, right? If we have 10 we will get 0. So we'll do the same thing here, we do a modulus of 10 here, right? So now we have the current head at 0. Okay, and what about the carry? So we need a carry from this sum now, which is, as I already said, is 10. We took the 0 and stored it here. Now we need this 1 from the 10. How do we get it? We can do 10 divided by 10. If it's any number like 12, other number like 12 or 13 or 15, and we divide it by 10, do we get this 1? Yeah, we definitely can get 1, like 1, we can get 1.5, and if we use any method like math.floor or something, we'll get that 1. So okay, so let's do that by saying carry is equal to sum, math.floor of sum divided by 10. Okay, so now our linked list is adding properly everything, and I can see that the carry is also okay. Everything is fine, right? We are moving the next to the next head, to the next head, to the next head, to the next head. Okay, and we are storing the 7, then 0, then 8, right? At the end, what will happen at the end? Consider we are at 3 and 4, then 4 is 7, 11 is null, and L2 is also null. In that case we will come out. What if there is one more extra number here, like we have here So there are 4 numbers, we are done. There are more 3 numbers. What will happen in that case? L1 is equal to null, but L2 is not equal to null. In that case, we'll be still in that loop. Okay. But what will be adding? What will be adding it with? Okay, that's a question. Anyhow, we are adding the carry, so that won't be an issue. I think we are doing right here. We are doing fine here, and I think we should move forward with running our code. But there is one more method, one more case remaining, in which the carry is left. Okay, we come out of this loop. Okay, and the carry is not in L1 and L2. The carry is separate. Okay, even after doing all these things, we come out. Okay, L1 is null, L2 is null, but the carry is remaining. Okay, these two are finished. Consider this is 9 and this is 4. We have 13, so we write 3 here and 1 at the top, which is carry. So if carry is remaining, we have this test case. We can write as carry is greater than 1, then we can write current head is equal to new list node carry. So like 708, I mean 3 and then 1. Got it? We should write it as next. Okay, I think this is fine. Let's run it and see what will the answers. We can get it wrong, we can get it right, but we need to see what is the answer. So the output is 7 here, so we just got 1 of this answer. Okay, so we are doing something wrong here. We need to check that. Are we moving our current head to the next node? No, we are not. So current is equal to current head dot next. Is it? Yeah, definitely. Because the thing is, unless and until we don't come to this head, consider 7. Okay, so we are at 0 here. What we did is we stored new linked list in here in 7. Okay, we are returning L3 dot next, which is nothing but 0 next. There is 7, and we are not incrementing, we are not moving forward ahead. So I think this is what was wrong. Let's check. Yeah, so expected answer here is wrong. In this case it is correct because there is only one number. Something is still wrong here. Only we are getting the first number. Okay, so we are doing current is equal to current head dot next. Okay, something is wrong. Current head dot next is equal to current new link new node, definitely, and then current is equal to current head dot next. Right. L1 is equal to L1 dot next. So what we see here is we are missing one more thing, which is we are not adding the carry here. If we completed one for loop and we are getting carry here, we need to add it when we are doing the next sum, so we miss that. And one more thing is, if we look carefully, then one more thing is this question, that why we are using and are you using and why not or earlier I wrote or but I just was confused what to write here, and or the thing is, if we write and, what happens is, if any of this list is longer, then it can stop. If the list is longer, it will stop. And if one of the list is shorter but other one still has elements, and we want to continue until all the we have exhausted all the digits in the longer list, in that case we I got this from the ChatGPT. If you're stuck anywhere to not known by anything, then you can just turn up to ChatGPT for not for the whole solution, just for explaining what is the wrong that we are doing here. Okay, I didn't search, so you just have to be sure what you're writing. If you're not, you can take help of ChatGPT to ask questions like where am I wrong and explain me this. So it's like a mentor or a teacher who explains you things like a kid also, if you tell him. Okay, so let's run this again and see what are we getting. Are we still wrong or we got a correct answer? So here we're getting at. So why is that? So we are returning L3 dot node. So where are we storing that dot net? And so after doing this change and adding the carry, hit the sum, our code looks perfectly fine, and now we can submit it again. Yeah, and we see that our code is submitted and it passes all the test cases. I've already submitted it once, earlier once, so I'm submitting it again, and it does pass the test cases. Yeah, we have completed our second problem. So let's meet for the third problem soon. Till then, have a great day and keep hustling. Bye.